Hi, geology students. In today's lab, or let's say this week's lab, we're going to learn two different things to do, and they're not exactly related, but they're both fairly short, so I've combined them into one lab. I don't think I'm combining them into one video, though. I think we're going to do a video on map scale and then another video on map locations. So this first one will be on map scale, this first video, that is. So what we want to learn really, when we're saying map scale, what we really want to learn is how to measure distances on a map. And this may be something you already know how to do, but it's something that you're going to be responsible for doing in this class. So if you don't know how to do it, this is, pay special attention here. So there are two methods that I want you to learn. When it's time to do this on an exam, I don't care which method that you use, but I want you to learn them both because they're excellent checks for each other. But regardless of which method you're using, the first step, and we'll talk about what these two methods are in a second, but the first step is always to have a piece of scrap paper. So you've got a piece of scrap paper, and this is true even if you have a physical map in front of you laying on a table, or if it's a digital map on the screen. So we get a piece of scrap paper and we mark the distance on there. Now what I mean by marking the distance with the scrap paper is that let me go to my little map here, is that I'm going to draw what appears to be a piece of paper here. I'm going to draw something, and so let's say you've got a piece of scrap paper. So it's a big rectangle like this, and it's blank. So if this was an actual piece of paper, this whole area would be white and would be covering up that map. And let's say that what I asked you was, I want to know the distance between Pine Bluff and El Dorado. Well, I'm simply going to mark those 2 points on my scrap paper. So there's the point that El Dorado is at, and maybe I would even put an E there to make sure I know where is where. And then that is the point where Pine Bluff is at. So there's my 2 tick marks. I now have a piece of paper with 2 tick marks. I now have what I need to measure the distance between these 2 points using either method. So let's look at what these 2 methods are. The first method is called, oh, and there's my map thing, but I'm going to leave that up there because I still kind of need it. The first method is called the bar scale. The second one is called the fractional scale. So let's have a look at the bar scale, what we mean by that. The bar scale looks something like this. Okay, I really wanted to leave that up there, but now I'm going to go ahead and get rid of it because it's kind of obscuring your view there. Bar scale is literally a bar with measurements on it. And with a bar scale, there's always a 0, and the important thing to remember is to keep track of where that 0 is. Notice that in none of these 3 examples is the 0 at the end. It's somewhere in the middle of the bar. Here's some more examples. And in all of these examples, 0 is never at the end. It's at the middle there, there. And so that's something that students can really get messed up on, is if they do not put the 0, or if they do not put their tick mark on the 0. In other words, this says that this is a 5-mile bar scale, but it's actually 6-mile bar scale because that's the 0, and from 0 to there is 1 mile, 2, 3, 4, 5 miles. From 0 to there is another mile. So really it's 1, 2, 3, 4, 5, 6. So always be aware, in the bar scale, always be aware of where the 0 is. Other than that, there's not a whole lot to worry about for the bar scale. It's fairly straightforward. So we're going to, again, move back to the Arkansas map, and let's assume I had the piece of paper again. Something like that. Now it's a smaller piece of paper, but it's still got the tick marks for El Dorado and Pine Bluff. I'm simply going to pick up this piece of paper and scoot it over to the bar scale and put one tick mark on 0 and see how far that goes and read off the distance on there. Now in this situation, you'll notice that from there to there is actually farther than from my 0 to 50 miles. So what I would do is mark 50 miles on there, which looks like it's going to be about there, but you won't estimate that. You'll actually have a piece of paper and lay it down on there. And then I'll go from there to there is another how many based on what the scale says. So bar scale is fairly straightforward, but not everyone really likes using the bar scale. And for those people, we have what is known as the fractional scale. The fractional scale is written as a 1 colon big number. So 1 to 24,000 or 1 to 62,500 or 1 to 250,000. Well, with the fractional scale, imagine each one of these 1 colon numbers are actually a fraction. So 1 to 24,000 should be thought of as 1 over 24,000, comma. 1 to 62,500 should be thought of as 1 over 62,500. So one way to look at the fractional scale is that is how much all of the land terrain features are shrunk down. Every feature on this map, every distance between 2 points is shrunk down 24,000 times. Every distance on this map is shrunk down 62,500 times, and so on. But the way that you use that is consider this fraction, this fraction to be the map distance divided by the ground distance. This means that one of any unit on the map is equivalent to 24,000 of those same units in real life. Or if the scale is 1 to 62,500, then one of any of those units is equivalent to 62,500 of those units in real life. So 1 inch on this map, because this is the scale, if the distance from there to there is 1 inch, then in reality, the distance from there to there is 24,000 inches. 1 inch from here to here on this map, in reality, is 62,500 inches. 2 inches from there to there is 2 times 24, 48,000. So the way that we use the fractional scale, it's a simple 3-step process. The way that we calculate distances using the fractional scale is a simple 3-step process. So we find the tick marks on our scrap paper. We've already done that. We've already got our scrap paper with the tick marks. And first, we measure the inches. Measure the inches from point A to point B along those points. With those same tick marks that we laid down on the bar scale before, this time for fractional scale, we're measuring the distance in inches. And if it is a fraction of the inch, make sure you convert that fraction to decimal. Oh, how do I convert a fraction to a decimal? You simply divide the numerator by the denominator. If your fraction is 3/16, you divide 3 by 16 on the calculator, and that gives you the decimal to plug in. So we're going to measure the inches, then we're going to take those inches, and we're going to multiply them by the denominator of the scale. In this case, the denominator is 24,000. In other cases, the denominator could be 62,500, 250,000, or whatever the fractional scale is. But we're going to multiply by the denominator, not by the entire fraction. So if you measured inches on a map of this scale to be 3 inches, so let's get this out again. Let's say we got 3 inches. Then 3 times 24,000 is 72,000. 72,000 inches from point A to point B, from one tick mark to the next. And that's all well and good. Oh, how do you like those zeros? I acted like I was running out of room, but I had room over there. Wasn't too smart. 72,000 inches is kind of a meaningless number. Who knows how far that is? Well, we want to convert that to miles. The way we convert that to miles is we simply divide by how many inches are in a mile. And that number is 62,500 inches. I'm sorry, per mile. So 72,000 divided by 63,360 is how many miles between one tick mark and the next. And the nice thing about being able to use the fractional scale and the bar scale is if you do them both right, they're excellent checks on each other. They will come out to being really close to each other within about 1/10 of a mile. So it's really hard to screw both of them up and get the same answer. So if you get a really, really similar close answer using both methods, then it's a pretty good indication that you did it right. So I believe the first 6 questions in this lab has 10 questions, kind of like a quiz. The first 6 questions, I believe the first 3 you're going to be measuring distances using the bar scale, and the other 3 you're going to be measuring distances using the fractional scale. So refer back to this formula. I'll post a hard copy of this slideshow onto this lab, but it is you measure the distance between tick marks in inches, multiply them by whatever the fractional scale is, divide by 63360. Use that formula, and as long as you're punching the numbers in, things should go really well. One problem with the fractional scale is it doesn't translate well to a computer screen because you could be viewing this at different scales. So instead of giving you a map with a fractional scale, I'm going to tell you on these questions, I'm going to say the distance was measured to be a certain number of inches and the scale is this. So all you will have to do is multiply by the scale I give you and divide by 63360. Literally, that's all you will have to do in determining fractional scale. The second video in the series will have to do with map locations, but I'm going to end this part right now.